In this video, I will look at some of the other common theorems just to whet your appetite to what they are and how to use them. I will also give you my advice of how I approach Euclidean geometry questions. And so just to wrap up the last three theorems, if we've got tangents, if two tangents meet at the same point for coffee, then those two tangents lines are equal from the point of contact to the point where they meet each other. If I have a tangent and a radius, they will always be perpendicular to each other. And then the last one, maybe the most common, maybe the most confusing, is if I've got an angle, it's called tan chord theorem. If I've got an angle chilling on the tangent itself, I like to draw a little arrow where it hits the chord. Then if you put your fingers on the chord that it hits, so if you put your fingers on AB and go with your fingers to the circumference, then that will tell you which other angle is equal to X. It looks very easy now when there's no other noise, but it can get a bit confusing later on. And so for that one, just remember the angle that's chilling on the tangent, you're going to draw a little arrow in the chord that it hits, put your fingers there and go across, and you'll get your other equal angle. To prove that a shape is a cyclic quad, normally a cyclic quad is a four-sided shape inside a circle, and so we can use all the properties like the opposite angles add up to 180. But if you're trying to prove some random shape, so here's your circle, but you've got a square, a quadrilateral just randomly here, then if you can prove that random shape has angles that add up, the opposite angles add up to 180, or if you can prove that it's got that bow tie, that angle and same segment feel, therefore conversely it must have been a cyclic quad. And so just keep that in your back pocket. Then the steps that I would go in circle geometry is fill in all the information as you read. So typically there'll be a paragraph that explains exactly what's happening. Typically what students do is they read the entire paragraph, then they go to the questions, and then they try and answer each one separately. My advice would be, as you read any little bit of information, like AB is the diameter, stop there immediately and just see, okay, if that's a diameter and this is the center, then these are all radii. If this is the diameter and I have a chord coming off there, then I know that's 90 degrees. And so you're just filling in bossies as soon as you've got the information. Mark off any radii like I've done here. I'm astounded at how often students don't mark off the radii but then battle later on in the question to figure things out. Always highlight the cyclic quads, and so as you get to a question, immediately just start your experience of that question by highlighting where the cyclic quad was. It looks all easy and pretty when things are simple, but when it gets big and complicated, that becomes invaluable. Ideal to get full marks. Don't forget about the good old days when you weren't so stressed out with things like sum of triangle, angles on straight line, exterior angle of triangle. Sometimes again that you've become so fancy with circle geometry that you forget the basics of grade 8. And then if you've had to prove something or work out something, it's generally advisable to look at that previous answer and use it for any subsequent questions. And then two other just bonus tips that are a bit left field is if you've got equal chords that are given, then magically the angles opposite those chords will be equal, and the reason would just be equal chords subtend equal angles. It comes from the rule when you've got angles in same segment, because imagine there was a chord here, AB, and obviously it's the same for both of these triangles, and so maybe you're getting used to angles in same segment. Now imagine I just cut this AB away and took this triangle here and just twisted it around the circle but kept the same length of AB, I might end up with a picture like this. And so those angles opposite the equal chord are the same. Very left field, but it's great to know that for when it comes at you. And then if no angles are given and you just have a bare picture, then if you're going to choose something to equal x, choose something that has a relationship with another angle. And so quite a common one is you've got a picture with a lot of noise going on and you realize this is a tangent. And so that would be quite clever to let that be x, and then the angle opposite would be x. And that often will let you just feel your way around a question. If this was the center, I would imagine I don't have the x's here. Maybe I would start by saying, oh, okay, because these are radii, I'm going to let that be y. The angle, sum of triangle would be 180 minus y. And so a bare picture suddenly gets a lot more flavor. So I hope that this was helpful just to introduce you to my way of doing Euclidean geometry. If it was, please like this video, subscribe to our channel, and share it with your friends. Thanks.